Hello and welcome back to our energy unit. Um, in our last lesson, lesson 5, we started talking about waves. And even though waves are not a form of energy, they are caused by energy. So that's why we're talking about waves in our energy unit. And then today we're going to talk about a specific type of wave, which is also a form of energy. So we're talking about the electromagnetic spectrum today. You may or may not be familiar with it, but by the end of the lesson, you'll have a better understanding of what the electromagnetic spectrum is and how it relates to waves and energy. Okay, so just a reminder from the last lesson, there are actually two classifications of waves. We have what's called mechanical waves, and then we have electromagnetic waves, which is what we're going to talk about today. Now, mechanical waves, if you don't remember, you have not watched lesson 5, make sure that you go back and watch that lesson. It's called Introduction to Waves. But remember, mechanical waves are waves that need a medium to travel. And today we're going to look at electromagnetic waves, which do not need a medium to travel. So that's the difference between the two. Now, electromagnetic waves and mechanical waves are similar in that they both carry energy. So remember, waves start with a vibration or a disturbance, and then they carry energy. And so electromagnetic waves, just like mechanical waves, carry energy. The difference is electromagnetic waves don't have to have a medium to get that energy from one place to another. So they actually can travel through the vacuum of space where there is no medium. Another thing you need to note about electromagnetic waves is they travel very fast. So specifically, I have the speed of light up here at 300,000 kilometers per second, which, to put that into perspective, can go around the world 8 times in just 1 second. So we're talking about super fast speeds here. And the electromagnetic spectrum is just a visual representation that we can use to see the different frequencies and wavelengths of some of those waves that do not require a medium to travel. So here in this picture, this is an example of the electromagnetic spectrum. And in this spectrum, there are 3 components. So you have like the color section, and you do need to know that these colors are in line with like the colors of the rainbow. So in elementary school, you may have learned about the colors of the rainbow in order as Roy G. Biv. That's going to be the same concept that we use for the colors of the electromagnetic spectrum. So Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. And those colors are aligned to different wavelengths and frequencies on the spectrum. And then we also have the actual name of the wave. So you can see here in the illustration, radio waves align to the red part of the spectrum. And then you have like the microwaves and X-rays and gamma waves that align to other color portions of the spectrum. Now, these waves can range in frequency, which means they can range in danger as well. So typically your higher frequency waves are your more dangerous waves. So your gamma waves, X-rays, UV rays are going to be your higher frequency waves. These are also your most dangerous waves. And then on the other end of the spectrum, you have like your microwaves and your radio waves, which can be dangerous in large exposure quantities, but typically are less harmful than those on the other end of the spectrum. So we're just going to go through each of the waves, and you'll need to jot down some notes about how these waves are used in real-world applications and how they can be found on the electromagnetic spectrum. So we're starting with radio waves. These are our lowest energy waves. Some real-life examples would include radio waves such as FM or AM radio waves. Radar also works off of this principle, TV waves. Again, they're very low frequency waves, so they're less dangerous than, say, your gamma waves or your X-rays. They do have the longest wavelength. So if you look at the picture on the screen, you'll notice in the range of the radio waves, you have lower frequency, longer wavelength. Now, next up, we have our microwaves. These are going to be associated with the color orange. On the spectrum, these are used for communication, some medicines, consumer use like microwaves. I want you to note where they are on the spectrum. And again, they're associated with the orange color. Then we have infrared waves. These are associated with the yellow color on the spectrum. They can be detected as heat, so a lot of times we'll see them used in infrared sensors. They can also be detected with special devices like light goggles. They're used in heat lamps a lot of times, and they are not quite as safe as radio waves or microwaves, but not quite as high frequency or harmful as, say, gamma waves or X-rays. Then we have visible waves. This would be representative of visible light, which we'll talk about in a future lesson. But these waves are found in the green section of the spectrum color chart. And a good example of this would be like sunlight or colors that we see. Next up on the chart is going to be our blue area of the spectrum. These are a little bit higher energy, higher frequency, shorter wavelength, so they're a little more dangerous. These waves can cause skin cancer. They can also cause blindness. So again, we see how dangerous they can really be. They're used in equipment that we're probably familiar with, like tanning beds and sterilizing equipment. So you want to limit your exposure to these types of waves. Next up on the frequency chart or the spectrum chart, we have X-rays. These align with the more purple or indigo portion of the spectrum. They have a lot of medicinal uses. They're used a lot in medicine, hospitals, industry. Astronomy uses them a lot, but high exposures to X-rays can cause cancer. This is why when you have X-rays done, they put that lead vest over you so that it can protect you from those electromagnetic waves. They are higher frequency. And then our highest frequency waves, lowest wavelength or shortest wavelength waves further out on the spectrum. These are in the violet category on the spectrum. These are our gamma waves. They carry the greatest amount of energy. They're going to penetrate the furthest, which is why they're most dangerous. They're given off by radioactive substances. So some of these radioactive substances can be treatments for some cancers like chemotherapy. Others are very destructive like atomic bombs. And some are very practical like nuclear fission is used to generate electricity. So gamma waves can prove to be helpful to us, but they can also prove to be harmful when we're exposed to them. Gamma waves are going to be something that we discuss a lot more in detail when we get into our chemistry unit, when we start talking about nuclear radiation. All right, so that we just moved through the entire electromagnetic spectrum. I gave you everything that you really need to know about electromagnetic waves. And I want you to pause the video now and answer these 5 questions. All right, let's go through the answers to these questions to make sure that you got what you needed to from the lesson. So question number 1, which electromagnetic wave has the lowest frequency? And hopefully you picked radio waves. This is going to be in the red section of the spectrum. Question number 2, which electromagnetic wave has the shortest wavelength? This is going to be at the opposite end of the spectrum, which are our gamma waves. So one more time, gamma waves have the shortest wavelength, highest frequency. Number 3, which electromagnetic wave is most dangerous to humans? And this is also the gamma wave. So because it has a shorter wavelength, higher frequency, it's also going to be more dangerous because it carries the most amount of energy. Number 4, which electromagnetic wave is responsible for the colors that we see? And that is our visible waves. And number 5, what's the relationship between wavelength and frequency? If you'll go back to one of the pictures of the electromagnetic spectrum chart, you'll notice that as the wavelength of a wave increases, frequency actually decreases, and vice versa. As frequency increases, wavelength decreases. So we say wavelength and frequency are inversely proportional to one another. So as one goes up, the other goes down, which is a really important concept to understand with regards to waves. So that ends our lesson on electromagnetic spectrum. Feel free to go back to the video and jot down notes if we move too fast or you miss something. And I'll see you in the next lesson.